Yeah, Mark, what are your opinions on that?
Why is everyone getting haircuts right now?
It's only Patrick.
No, but there's also like 2 other people.
This man,
I know.
Here.
still popular.
Yeah, you get haircut.
What's that?
Wait, I got a haircut.
Bro, do a middle. Bro, do a
Look, I
middle.
don't have that.
I don't know.
I can go like this. You? I like how music. No, but hold it, it's crazy. That's double.
Yes.
I never got around to doing anything else, and I just talked to
I'm gonna go to like.
Okay, grade 9, please. Let's start. Rational functions. You will be surprised today by new concepts. Could you please pick up the calculator and divide 10 divided by 10? 1. 10 divided by 10 is 1. How much is 10 divided by 9? 1.1. So when the denominator is less, the answer is more, right?
Yes.
Now let's do 10 divided by 5.
2.
What did you notice?
Double.
When the denominator became half, was double, right? Wait for the surprise. 10 divided by 4.
5.
What did you notice?
It's getting more
The answer is more. 10 divided by 2.
5.
What happened? The answer is more, right? Okay. 10 divided by 1.
10.
What happened? The answer is the same, right? Why? Because we always will divide by 1. The answer is the same, right? Thank you. 10 divided by 0.9. Is it 11.1?
Yeah, 11.1.
What did you notice? The answer is more than the original number, right?
Yeah.
Good. 10 divided by 0.6.
16.6.
16.
What's happening? Oh, yeah, wow.
Okay. Now let's do this. 10 divided by half or 0.5.
20.
20. What happened?
Oh, when you divide, and so if you have a half, and you flip it, it's 2.
If we always divide by a half, what happens to the original number? Doubles? Okay. 10 divided by 0.4.
25.
Oh, okay. 10 divided by 0.1. Is it
I think
100?
it's 10.
Oh my God, the answer is 100. Okay. 10 divided by 0.001.
1,000.
Oh my God.
1,000. I don't know.
10 divided by 0.50, then 1.
Wait, 5 more after the dot?
I think
so.
Of course, yeah, after
No,
the
1
dot.
million.
10 million. No, it's no. You divide by 0.6. Wait.
Million?
10 million. 10 million.
What did you notice?
Oh, okay.
What did you notice?
It's 1 million.
Went to zeros.
10 divided by 0.00001.
of zeros is 1 million.
The answer is 1 million. Okay, let's do this. 10 divided by 0.10 zeros, then 1.
Billion. That's what the fancy word.
Oh wait, my calculator said error.
What happened to the answer?
Error.
Why error?
So many. We can't fit all.
Don't tell me we cannot divide by
Oh, 1 trillion.
1 trillion.
1 trillion. So some calculators couldn't show you the answer because it's so
Well, no, because you have to put it sideways.
great, right? The answer is so great. The number is so great. Whereas others, like a computer, can give you the answer, like let's say 10 trillions. What did you notice? We started dividing 10 by 10, the answer was 1. And now when we divided 10 by 0.01, the answer is almost infinity. What happened? G?
The way I think about it, it's like, for example, let's like 0.5. Like, if we're dividing 10 by 0.5,
Yes.
it's basically asking how many 0.5s are in the number 10. And if there's 0.5 plus 0.5, so 2 is in 1, it's just double. So like, if you slowly go down, I just,
What happened when I went like very fast down, like 0.0s, then 1?
it grows a lot.
it grew more, right?
Isn't it like 10 times if you
What?
flip the number? If you move the decimal point to the end and move the one.
Then add zeros to the 10, so it's gonna be 10 trillion. Very good. I have a question, please, you. Yeah. What is the sign, which is positive or negative, of 5? Positive, negative 3. 0. Is 0 positive or negative?
Neither.
Neither? Okay. What about 0.1? Which one is greater? 0.1 or 0? Okay. What about negative 0.1?
0.1.
It's negative, right? So it's less than 0. Okay. Order from the least to the greatest. 1, negative 1, 0. Good job. What about these? Negative 0 point hundreds of zeros, then 1, 0, and positive 0 point hundreds of 0, 1.
Negative
0, then positive 0.0001, right? If the answer is extremely, or the number is extremely little, like 0.01, we can call that in math 0 positive.
0 what?
If the number is a little bit under 0, like let's say negative 0.0, then 1. We can give it another name, 1. 0 negative. Now order from the least to the greatest. 0 positive, 0, 0 negative.
0 negative 0.
0 negative less than 0, and 0 less than 0 positive. Again, what is the one of them that represents nothing? 0. What about negative 0.000001? Does it represent something? Yes, but it is extremely like less than 0. Like it's just under 0 with like less than millimeter, right? What about 0 positive?
It's less than
Slightly
a
more.
millimeter above 0.
Yeah.
It's a number which is existed,
It's like 0.
but it's very little. The number is very little or small. It's just a little bit above 0. We call it 0 positive. Okay, now let's divide again. 5 by 0 positive. What is the answer? When you divided 10 by 0.00001, what was your answer? 10 trillion, right? What if I increase the zeros, 0 point million zeros, then 1? What will your answer be?
5 and then a million zeros.
What is the biggest number or greatest number you can imagine? Infinity. What about this? 5 divided by 0 negative.
Negative.
What did you notice?
It's cool.
Can we divide by 0 in math?
No.
I told you, this is the crime in math, it's the error. No one in the world can divide by 0. If I give you $5 and I say divide it by nobody, how much will? Who? There's no one. Get? No one. So, it's not an operation in math. You cannot divide by 0. But, we found alternatives. We can divide by 0 positive and 0 negative. Just remember that. Always dividing by 0 positive or negative, the answer is infinity. Which, again, 0 positive is a number, but it's unlimited. 0.0 is not finishing, then 1. That means the answer is a number which is very great, but not finishing, unlimited, which is infinity. So again, you can like consider that 0 positive is kinda not existed, like infinity, because we cannot reach it. Mr. Nizar, how? You said 0.100 zeros, then 1. It's limited. But I didn't say 100 zeros. I said 0. Unlimited zeros, then 1. But this is not a 0. This is a little bit like a cell or like an electron above 0. Something very tiny above 0. But it's not 0. It's not nothing. It's something. But very tiny, like a cell or electron in physics, you know, or in biology. That's why infinity is not existed, because 0 positive is not existed. But now let's imagine, and I'm not talking about imaginary numbers, I, the root of negative 1, no. Let's imagine that 0 positive exists, that means infinity exists. But since x will never reach 0 positive, that means y, the answer, will never reach infinity. So we cannot write that in math. Don't ever write equals before infinity, because nothing in the world can reach infinity. Don't write equals, please. Don't write equals. You cannot say my money equals infinity. How much do you have? Trillions of dollars? This is nothing. This is much less than infinity. Infinity is, you cannot imagine. It's something not ending, not ending. If you say 1 and trillions of 0 on the right, no, infinity is more than that. Also negative infinity. Instead, we do that. Let's say fx equals 1 over x. If x approaches to 0 positive, that means from up, comma, y approaches, divide 1 divided by 0 positive, positive infinity. We cannot say y equals to positive infinity. We say y approaches, which means getting closer and closer and closer, but will never reach positive infinity. What if x approaches to 0 but from down? Like 0 negative. What will y approach to? Sorry? 1 divided by 0 negative. Negative infinity. Again, this is in a lesson called limits. You will learn it maybe in grade 11, not now. But since you are an advanced class in grade 9, I have to teach you that to go forward for the asymptotes and rational functions. I needed to teach you that. I know it's above your level now. It's calculus. It's really above your level. But it seems like you got it, because you are a smart student. What do you think our lesson of today is? Can you say that as a question? Learning objective? What is our learning objective? Sorry? What are rational functions? We said about that. We talked about that. They are any function that has x in the denominator. For example, 1 over x, 3 over x squared. What if there is no x down? Like let's say x over 5. What function is that?
Linear function.
Linear, because it's 1/5 x, which is mx plus b. For rational functions, there are 3 cases. I will make it extremely easy for you, grade 9, because we teach this to grade 11 in Algebra 2 or pre-calculus. But you are in an advanced class, we will teach you from now Algebra 2 and geometry. So I need to teach you that in depth. But I will try to be easy, okay? It's not difficult, just focus with me. There are 3 types of rational functions. One of them, when the degree of the numerator, I will call it up, greater than degree down. Let's say x power 3 up, but x power 2 down. So the degree up greater. And degree up equals degree down. Again, I'm saying up and down instead of saying numerator and denominator because they are long words. I don't want to write a lot.
You go degree wrong.
First one.
It's the R in this.
Thank you. And here degree up less than degree down. Give me example about this. Example. Let's say x minus 1 over x squared minus 3x plus 2. What did you notice? What is the degree up? 1. Degree down? 2. The highest power. Degree is the highest power. So up less than down. Can you give me an example about this?
X over x, or x minus 1.
Can you add something? X minus 1 over 3x plus 2. What is the degree up? 1. Degree down? 1. So they are equal. So the graph will be different, huh? Carlton, what's the difference? Example, please.
fx equals
Degree up greater, huh? Be careful.
x to the power of 3 minus 2
Over 2, let's say.
over
Over.
x minus 1.
Good job. Or 11. Let's change 1. Degree up is 3, degree down is 1. These are 3 cases. I will start with the first one. Be careful, there is something here called asymptote. Have I explained asymptote before? Okay. Let's say this is example. Don't write this. X and 1. Okay, guys? This is a line. Let's say called x equal negative 2 because it passes through this point. If your graph gets, or curve gets closer and closer and closer and closer and closer to this line but will never touch it, we will call this line asymptote. It looks like the street in front of your house that will never touch the fence or the wall of your garden or yard. You call it yard in the States. Why? Because there is a sidewalk, right, between them. We call this street asymptote. It gets closer to your house, but it will never touch it because there's a space between them. So we call this asymptote. For example, asymptotes can be horizontal, not only vertical. If I have a function that is increasing but getting very close, like the battery of your phone, when you charge it, the current will be, let's say, 1 ampere. Will be very close, then it shows you 100% charged, but actually it's not 100% charged. It's extremely close to 100% because if there is one electron not there, that means it's not 100%, and you cannot see electron. So in physics you will see this graph one day. So it's getting closer and closer to 1 ampere. So we call this line y equal, let's say 1 asymptote. How to write asymptote? P letter is silent. Asymptote. So you need to get familiar with asymptotes because you will see them in many functions, in exponential, in logarithmic, in rational, maybe in radical, who knows. But till now, with linear functions, it's a line, right? There's no asymptote. With quadratic functions, parabola, there's no asymptote. But now you will see something new, that there's a line and your graph is getting closer to this line. What does that have to do with infinity? We will see now. Ready? Appetizer is done. Now the main course. Ready? Okay. I will delete this and give this to you in a very easy way. First of all, what do you need to find?
The domain and range.
Domain. Let's forget the range now. Domain. How to find the domain in a rational function? Yes, Maxime?
Don't you have to set the x to 0 or the bottom is 0?
x0 or the whole
The
thing?
whole thing 0.
Denominators cannot be 0. This is the condition. Like, if I am a rational function and you want to graph me on Desmos, I will say, wait, I cannot be divided by 0. Be careful. So you need to you need to delete
Right.
this value. X minus 11 doesn't equal to 0, so x doesn't equal to 11. And I taught you that last Friday, right? When you see x doesn't equal to 11, that means x equals to 11 vertical asymptote. Do you know why vertical asymptote? Because if the graph crosses it, that means x equals 11, the function will be angry. Will have a heart attack. Why did you divide me by 0? I told you. That's why your graph gets very closer to 11. It can get 11.01, but will never be 11. And it can come before 11, 10.9s, but will never be 11. Remember, x cannot be 11. Easy? What did you learn? What type of vertical or horizontal? Vertical, because it's x equals to a number. Now, how to graph it? By the way, here in first case, case 1, guys, there is no horizontal asymptote. Just remember that. Because in these cases there is, Be careful, guys. Here, there is no horizontal asymptote. Easy?
Okay, everybody's here?
Yeah, I think you.
Oh, yeah, sorry, okay.
They told you that Nikita gave it.
Oh, yeah, that's right, that's right, that's right.
Easy, guys. Now how to draw it? You draw a table and try to get helping points. Pick up the number 11. Can you take two numbers before it and two numbers after it?
10 and 12.
9 and 10, 12 and 13. Now I want you to substitute them here. Can you? 9 cubed minus 2 times 9 squared divided by 9 minus 2. What is the answer? Please, somebody can calculate 10, somebody can, I need your help, guys. Don't do the first one, try to start from the
Use
end.
a calculator for the time.
You need calculator, yeah. 9 cubed is 790, 972, something like that.
729.
729 minus 2 times 181 minus 162 divided by negative 2.
567.
283.5.
283.
Negative 283.
Yeah.
Negative?
Yeah, it's negative 2 on the bottom.
What about 10?
Negative 800.
Sorry?
Negative 800.
Negative 800?
Yeah.
What about 12? Calculator can give me the answer. And somebody please calculate 13.
I'll calculate.
1,726.
It's positive, huh?
I got negative
that's just the
720.
top.
Wait, for 12 how much?
For 12. Negative 720.
Oh, no, wait, you're right.
Negative or positive?
No,
Negative.
No,
I got
14.
positive
It
1,726.
can't be positive because the denominator is negative.
I got 14.
Why? 12 minus 11 is positive 1.
Oh.
I got 1,726.
I got
Very good. What about
1,040.
13?
I got
Wait, yeah.
Wait, I don't think.
For 9, it's at 283.5.
It's okay. Because the number is so great, so I don't.
99.5.
13.
yeah.
99.5.
929. Good. Good. The numbers are so great, but please focus here. How can I put these numbers there?
Yeah, it's
Yeah.
99.5.
I will definitely round. You will see now. Where can I put 2000 here?
How'd you get 17?
Now, the first thing you do is the asymptote. How to draw it? Where is x equal 11? Let's say this is 5. This is 10. So 11 will be here. It looks like the line of symmetry, do you remember in the parabola? So you write here x equals 11 asymptote. Why did I write the word asymptote? To remind myself, be careful, your graph cannot touch it, cannot intersect it, cannot cross it. It's like a red line, it's principle. You know, like when you have principles? It's my principles, I don't want anybody to cross it. It's the same thing here for this function. Where is 9 and negative 200? Maximum I have negative 800. I will do negative 200, 400, 600, 800 here. I have 9 and negative 200 there. 9 and negative 200 here. And I have 10 and negative 800. 10 and negative 800 here. That means my graph will look like that. Can you see here that my graph didn't intersect the asymptote?
That means
Barely.
12 is wrong. Something. I think it's
Wait,
12 is how much?
1,440.
you need to minus
Yeah, that's
Okay,
what I got.
288.
400, it's okay. Now let's try 12. Where is the 12?
1440.
1440.
It's okay, it's okay.
I think 1728.
12 and 1,400. Let's do
Minus 2.
200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600. I divided it just to finish. Now I have 12 with 1,400. 12 is 11, 11 is here, is 12 is here. 12 with what? 1,400. So here. 13 with less. 13 with 900, which is here. This is closer to the line, that means your graph will pass. Be careful. It will never be parallel. It will be closer to it, but it will never touch it. It will never touch it. Be careful. Now I want you to focus here. When x approaches to 11 from down, y approaches to what? This is the most important thing. This is limits, huh? Grade 11. Focus, please. Don't try. Let's substitute a number less than 11. 10.9? 10.9 minus 11? Negative 0 point. Which is 0 negative. So here I have 0 negative. Up, substitute 11 as it is. I don't have any problem if the numerator is 0. My problem is down, which I survive now by substituting a number closer to 11, but not 11. 11 cubed, guys, how much?
121.
Cubed.
Oh,
Minus 2 times 11 squared. Can you give me the answer? It's positive, right? How much?
11 cubed?
Minus
1,010.
242.
minus 242.
Wait,
Calculators, how much?
Wait, 1,330.
Positive, 1,000 something.
1,089.
Positive divided by negative,
Negative.
so negative infinity. Let's go here. When x is before 11, don't write, look at the board, please. When x is closer than 11 but from down, y was negative infinity here. Yes. Let's do x approaches to 11 from up. Put a number more than 11. 11.1 minus 11, 0 positive. 1,000 and up, above, up, substitute 11, no problem. 1,100 divided by 0 positive. Y approaches to positive infinity. Let's see there. When x gets closer to 11 from the right, but x is bigger, greater than 11. What was y? Positive infinity. That means I didn't make any mistake. My answer is correct. So please, guys, memorize this, or just understand the technique, how it works, because we will use it always here and here. This is case 1. In most of the cases, it will look like that. It has 2 parts with one asymptote in the middle. Sometimes it gets closer to the asymptote from up. After the asymptote, it gets closer to it from down. Or the opposite. Clear? Easy? Now, do you want case 2, or I give you another question, you do it alone on case 1? Another question. I will keep this on the board and I will write a question there, and it's your turn. So that's all about case 1. The question will be on the screen. Thank you for watching. 28 minutes.